Test your biostatistics knowledge. Here we have an estimated odds ratio, and it's 95% confidence interval. An epidemiologist wishes to test for an association between a certain risk factor and a disease of interest. From the table above, the appropriate decision A could be a type 1 error. B is a type 1 error. C could be a type 2 error. D is a type 2 error. Time to think. And the correct choice is C. A type 2 error is possible. The reasoning. First thing to do is ask yourself, what is the null hypothesis? Time to think. The null hypothesis is that the odds ratio, the true odds ratio, is equal to 1, which is the same as saying there's no association between the risk factor and the disease of interest. The next question to ask yourself is, how do I make the appropriate decision? Time to think. Since the confidence interval captures, that's the word, the hypothesized parameter value, the appropriate decision is to fail to reject the null hypothesis. Let me explain. See how this lower bound of this confidence interval is less than 1? Now 1 is the hypothesized parameter value. An odds ratio of 1 means the numerator is equal to the denominator, which means there's no association. So if the lower bound is less than 1 and the upper bound is greater than 1, then this confidence interval captures the hypothesized parameter value. Now, another way to look at this is to say the lower bound means there's decreased risk because it's less than 1. The upper bound means there's increased risk, 185% increased risk, to be specific. Because this bound, the upper bound, is greater than 1. So having a lower confidence bound that suggests protection, decreased risk, and having an upper confidence bound that suggests risk, protection, risk, they don't agree. That means there's too much variability in this point estimate for it to be statistically significant. And so this would be called a non-significant association. Possible risk because it's greater than 1, but non-significant because the bounds don't agree. Non-significant means we fail to reject the null hypothesis. Now we can ask ourselves, what is the possible error? And we need to know the definitions for type 1 and type 2 errors. Since a type 2 error is the act of failing to reject the null hypothesis when the alternative hypothesis is true, a type 2 error is possible, but of course it's not guaranteed. Now, from page 84 of my book, College Stats with Early Hypothesis Testing, we have a diagram that really explains the two types of correct decisions we can make in statistical hypothesis testing and the two types of errors we can make in statistical hypothesis testing. So, the human being doesn't know which hypothesis is true, because if the human being knew, then the human being wouldn't spend money and time studying a topic. You would just know. But if the null hypothesis is true, and we collect the data, and we crunch the numbers, and we make our appropriate decisions, well, we have two possibilities. We can either fail to reject the null hypothesis or reject the null hypothesis. But in this problem, the appropriate decision was to fail to reject the null hypothesis. And so, because of that, if we fail to reject the null hypothesis, either we make a correct decision when the null hypothesis is true, or we make a type 2 error when the alternative hypothesis is true. But of course, the human being doesn't know which hypothesis is true. So a type 2 error in this case is possible, but not guaranteed. And with that, this is Dr. J. Lee Noose for College Statistics.